Now let us start the exercise 1.2. We have seen already introduction, type functions and types of the functions, and before that I want to give you the one suggestion already I have given to the other classes. While you are spending time due to the while you are spending time on mobile or any screen, laptop or computer, take care about your eyes. So because I have faced the problem, I am explaining you. So take a 20-20-20 formula, and when you watch the any screen for the 20 minutes, give the 20 seconds of relaxation to your eyes and see the a thing which is a 20 meters distance, minimum 20 seconds, so that you will get the relaxation. Give the gap and go on working on your notes, and make the notes. If you are not finding the any notebooks, as the lockdown is going on, libraries are closed, so if you are not finding any notebooks, then you do any rough notebook, rough paper or any rough notebook. If you are finding, go on solving them, and if you have any type of the doubts, then you are very free to ask me. Now let us start the exercise here. 1.2 here. So the first question is f of x is equals to 1 by x is 1 1 and onto, where r star is the set of the real numbers. Is the result true? And if the domain. So already working rule we have discussed in the previous class, that is to prove that one function x1 and x2 should be taken in domain, and assume that f of x1 equal to x2, and after solving we need to get x1 is equals to x2, so that the function is here, it is clearly explained to you. So let us take x1 belongs to x2 belongs to the r star, and assume that f of x1 equal to x2. f of x1 बोले तो 1 by, as f of x is equals to 1 by x, so f of x1 is equals to 1 by x1, f of x2 is equals to 1 by x2, and after that then you are going to get x1 equal to x2. We have reached that, therefore this function is a 1 1 function. And to check the 1 by 2 onto function, you consider here this slide is you got first. So let us take here the working rule is we need to take the one element which is present in the codomain, and we need to equate that, that is equals to, there exists x such that f of x is equals to y, and that x should be belongs to the domain. So now let us see that y belongs to the non-zero real numbers. R star is nothing but y is equals to f of x, as f of x is equals to 1 by x, 1 by x is taken, so x is equals to 1 by y. Now here for all the y is taken from the codomain. Codomain is set of the real numbers, non-zero real numbers. Any non-zero real number you take it here in the place of y, then x will be again non-zero real number, so that's why x belongs to the domain. So x is belongs to r star, as y is not equal to 0. If y equal to 0, then it is not defined, so therefore it is an onto function. So now if r place is replaced by n, then whether the r star is replaced by the n in the codomain, with codomain being r star, codomain r star only, but the domain is r star is replaced. So the new function g from here n to r star is given to you. Okay, so now here let us take the x1 x2 belongs to the natural number g of x1 equal to and x1 equal to x2, therefore it is 1 1 function. And y belongs to the codomain, here the codomain is r star, and y is equals to f of x, x is equals to 1 by y you will get, and y is any real number. If you take x will not be a natural number. Suppose y is equals to, in this place here if I take the y equal to 2, then x equal to 1 by 2. 1 by 2 is not a natural number, so that's why it is not an onto function. So let us go for the next second problem here. Check the injectivity and surjectivity of the following function. What is meant by injective? Injectivity is nothing but 1 1 function. Surjective is nothing but onto function. And the function is given that f is equals to here natural numbers to natural numbers, given by f of x is equals to x square. x1 x2 belongs to the natural numbers. Let us assume that f of x1 equal to f of x2, and x1 square is equal to x2 square. As x1 and x2 are the natural numbers, x1 equal to x2. Why? Because natural numbers squares, any two numbers squares if you are taking, they are equal, means compulsory they should be equal. Instead of the natural number, if it is given any integer or any negative number it is present here in the place of the x1 and x2, here in the place of x1 and x2, then what do you get here? we will not get it. Then we will having such type of the problem in the next coming, and therefore it is injective. And y belongs to the natural number codomain. Let us take y is equal to x square, x equal to root y. We will get in the place of y, if you are taking any natural number, x is equals to any natural number, not suppose if you take the 4, x equal to 2 you will get, but it is a natural number. But in the place of y, if you are taking here, in the place of y, if you are substituting 2, then x equal to root 2, but root 2 is not a natural number, so that's why x does not belongs to the natural numbers, as root 5 is not belongs to the natural number, the reason, hence it is not a surjective. The next question is given to you, same function by changing the domain and codomain to the natural numbers. Now here if you see that x1 square, x2 square, 1 square and minus 1 square both are equal, because 1 square is 1, minus 1 square is also 1, so 1 is not equal to 1, so therefore it is not an onto function, sorry 1 function. And let us check the onto function, how it is possible. It is not an onto function. So like this you can go and solve the problems here clearly. Third problem you can do it. Fourth problem, it is f of x equal to x cube is given to you. Let us take this problem here, x cube, f of x is equals to x cube. So if x1 x2 belongs to the natural numbers, let us take and assume that f of x1 equal to x2 and x1 cube is equal to x2 cube, that is nothing but, as both are the natural numbers, x1 is equals to x2. So do remember that, and therefore it is injective, and it will not be a surjective. Then you copy this one into your any notes and complete the notes. Okay, then after, if you are not finding any notebooks, fair notes, then you can do it in at least rough column. Okay, note and keep it with you. Next one is integers. It is given that here in this case of the integers, square whenever it is there, x1 is may not be equal to x2, but as the cube is there, then it is x1 is equals to x2 we are going to get. So therefore it is an injective function. So y belongs to and it is not an onto function, surjective. Now let us go for the third problem, greatest integer function. Greatest integer function. So let us have once have the discussion about the greatest integer function. Greatest integer function is nothing but that will be represented in a brackets. Suppose if you are taking as an example 1.5, what is the meaning of this one? The greatest integer less than or equal to 1.5. That means take a number line, easily you get to understand. Here 1 will be there, here 2 will be there, 1.5 will be here, 1.5 will be there. Okay, so now if you are taking here 1.5, the less than 1.5, what are the integers are present? 1, 0, minus 1. In all these, greatest one is what? 1. So therefore this is equals to 1. As a result, you are going to get only integers you are going to get. Suppose as an example, if you are taking, what is the greatest integer? Minus 1.5. Most of the students will get confused with this. Is equals to means minus 1, they will say. No, minus 1. Take a number line. If you get confused, take a number line here like this, minus 1 and minus 2. Here minus 1.5 will be there. Less than minus 1.5, what are the integers are present? Minus 2 is there, minus 3 is there, and therefore the greatest one in all that is minus 2. So here the result will be equals to minus 2. This is a basic thing about the greatest integer function, and keep it in your mind. And let us see the problem here. 1.5, 1.6 belongs to the rational numbers domain. Let us consider. So both are equals to 1, as I said to you, but 1.5, 1.6 are not equals to. Now here images, whenever you see that, all the images are only the integers you are going to get. Whatever it may be the domain number you take in the domain, images you are going to get integers. So non-integers will have the no pre-image. So as for 2.5, if you are taking in the that, it is not an onto function. Now to make this function as an onto function, can anyone guess that what change can be done? To make this function as an onto function, here we need to change the codomain to what? If you take from real numbers to integers, then this function is a 1 function as well as onto function. So do remember that. That is another question. If it is given a small change in the examination, sometimes the questions may be asked to you like that. Instead of that, the question may be given to you that don't remember that greatest integer function, if it is given that it is a 1 function and not onto. No, domain and codomain will play the key role in these cases. Okay, so let us see the next modulus function. So modulus function also the same way, it is not 1 1 function, as because you are going to get the minus 1 and plus 1 if you are taking the images will be, it is not an onto function. So can you guess here for what values for the function, what if you are changing here, for what function you are going to get it as a onto function, 1 1 and onto? Can anyone guess? And guess and reply to me afterwards. Okay, so like this every question you need to think, whatever it may be the question is given to you, you are not supposed to stick to that question only. You need to come out of that, you need to frame a new question so that it is an easy task to you to do the problems. Okay, so now let us go for the fifth problem here. The fifth problem is sinum function. Sinum function, if you are taking 1 and 2, f of 1 equal to 1 you will get, as it is x greater than or equals to 2, 1 and 2 are both are greater than 2, then f of 1 is 1, f of 2 is 1, so 1 is not equals to 2, then if it is not 1 1 function. And here the images, if you are taking only 1 0 minus 1, so if you are having that, other real numbers are not having any pre-images, other real numbers will not have any pre-images. So if you take as an example 2, if you are taking in the codomain, there will not be any pre-image for the 2 in the domain. So this is the main thing you need to observe here. Main thing, if you are observing, then you can understand very clearly. Okay, so now let us go for the next problem. That is here it is not onto function. The next problem is, it is very simple, I think you can solve it, whether it is 1 1 or onto. So I am going for forwarding this one, and let us move for the next slide here. Next problem is seventh one. F of x equal to 3 minus 4x is given, and same procedure, x1 equal to x2 you will get. And how to find out the, yes, it is onto. Why? Because if you take any real number in place of y, whether here most of the students will get confused whether it is an onto or not, to decide how. Why any, here this function is defined, why we are taking from the real numbers codomain. Any real number if you take, x will you get a real number or not, you need to think. If it is not satisfying, then it is not an onto function. So let us go for that, is bijective. Bijective is nothing but the function which is both 1 1 and onto is called a bijective function. Now let us go for the next problem. It is given 1 plus x square, it is given to you. 1 plus x square means, in yes, as the in the, sir, x square is equal to x1 square equal to x2 square, here it is given, previously you have written x1 equal to x2. That case is actually the natural numbers. If it is includes the sets, if there includes any negative numbers, x1 will not be equals to x2, so it is not equals to x2, so it is not a 1 1 function. Let us go for the images of f will positive real numbers, all you are going to get a positive numbers. Negative real numbers will not have the any pre-images, so that's why you are going to get a, it is not an onto function. Now let us move for the next question, eighth one. This is very simple here, but ordered pairs should be taken into consider. The solution I am giving to you, I think you can understand very clearly. How do we check here? So it is bijective. Let us move for the next. This is very important actually, and maybe a little bit confusion. So let us take the two numbers from the natural numbers, two natural numbers whenever it is defined. F of 1 is 1 you are getting, f of 2 is 1, so 1 is not equals to 2, then hence it is not 1 1 function. So onto function check. To check the onto function, what to do? We need to take the any element from the codomain. That codomain is natural numbers. Let n is an order and n belongs to the codomain. So then odd numbers will be in the form of 2r plus 1. They will be in the form of 2r plus 1 as it is mentioned here. Okay. So now here, then there exists 4r plus 1 in the natural number, such that f of 4r plus 1 is equals to, sir, how do we, from where did you get that 4r plus 1? You may get out. As we are taken here, generally the format will be there. If you substitute 4r plus 1, 4r plus 1 as that number is taken to you, it is an odd number. Here we need to concentrate that here n plus 1 by 2. In this, if you are substituting 4r plus 1 by 2, if you are taking 2r plus 1 will be you are getting. So 2r plus 1, as you are getting 2r plus 1, there exists one number 4r plus 1 in the natural numbers only. such that in the domain, that means in the domain such that you are going to get. So that's why you can check. And n is an even. Whenever you are taking even numbers will be expressed in the form of the 2r. So there exist 4r such that f of 4r is equals to 2r plus 1. 4r by 2, that is equals to 2r. So therefore it is an onto function. Now let us move for the 10th question. So here this solution I am giving to you, I think you can understand, and you do this problem here as an homework only. This is also very simple question here, whether multiple choice it is given to you, but you need to do the solution and try to understand it. I am keeping it for a second. Next, the last question, 12th question, it is also given to you, the multiple choice question. Easily you can do it and complete the notes and as early as possible, and whatever the doubts you are having, you try to ask me. Okay, thank you.